So to give some background what this is going to be about, so we have two releases of the KNIME software every year, and what that session is going to be about is that we'll kind of show some of the highlights of the new features, etc. That is essentially like two releases. It's what happened since the last summit that we had here in the US. Why do I do that? I'm part of the engineering team. I'm part of the development team. I'm involved in many of those discussions. I do part-time development also. So I should be able to give all the details. But we also have different people from the team come up here and present these different topics because they are sort of the subject experts. Whenever you have something interesting to talk about and you want to have more details, and you just come find us. There are also these demo stations outside. They are not actually at the registration area. We can show that to you. Since that's too much to show, we just picked some of the highlights. They're shown here. We tried to split that up also so that it naturally fits into two, let's say, not really use cases, but also not really stories, but two data sets that we kind of try to analyze. That didn't always work out. But we did our best. This is also naturally fitting to this picture here that Michael already showed. So in the first part, we mostly concentrate on what has happened in the open source part, so in the KNIME Analytics Platform. And then on the second part, we also look a bit on to how to deploy this, run this on the KNIME server, make a REST service from it, and then also looking into the web portal and guided analytics. But before we do that, a few announcements. Michael has kind of highlighted some of them already, but I'd like to give some more details. What has changed in, let's say, in the last year. The first one is that, KNIME has been open source since the beginning, but starting this year, the KNIME source code is also available on GitHub and Bitbucket, so we have our code there, or let's say large pieces of our code. It's an ongoing effort. Our code base is quite large, but it gives you all the details how to also then start developing custom extensions if you like. The reason why it's not completely there is this was quite some effort. We used to have everything in internal code repository in Subversion, and then we had quite some stressful weeks to get this all converted into Git. Just computation time to do all the conversion was more than 3 weeks. It was very early in this year. The KNIME code is, let's say, we started this in 2004, so it's quite a large code base, but it's very modular. So there are in total more than or about 70 different repositories. So repository is something like the R extension, the Python extension, the KNIME core, the Spark extension, server, the Tableau extension. So all of these things are different, hosted in different repositories. Most of them are open source. The KNIME server is not. The code base is something like 20 gigabytes. So it's not just source code, but also some models. For instance, our text mining extensions comes with some models, which we distribute as part of the build. So they are contained in that also. Or there is also an R binary. There are about 1.7 million lines of code, mostly Java code, JavaScript code, and also a bit of, when we talk about Python and R integration, there's also Python and R code in it. There's a large collection of tests, and there's numerous unit tests, but also like complex workflow tests for different versions, and there are different different stages how these tests are run, so that's quite complex. And this is still ongoing, and we publish more and more of our repositories onto GitHub. So just go there and check it out. What we have also published is 90 builds. So if you are interested in any of the new features that we've put in since July, when we had the last official release, you can go and get it from the KNIME website. there's a search box, just enter likely build, and you will come up here. We also drafted this box really, really carefully to make sure that you understand that you don't shoot yourself in the foot. It's not production quality. These things get tested by the team because it's part of the development process, but after all, it's a nightly build, or here it's more like an afternoon build. All right. Michael also mentioned that we have open sourced some of the extensions that used to be commercial. The personal productivity extension is one of those. It's been open source in the July release, which is 3.4, and that's the personal productivity extension is let's say a set of useful tools that make it easier for you to design these workflows. They're listed here. There's something like a workflow diff, template handling, calling out to other workflows, etc. I have a few slides here, but so my question is, who of you is aware of something like a workflow diff? Yeah, okay. It's like a handful of tools. And the NIMers also, which makes me really glad that the NIMers know what the workflow diff is. So the story here is Manling and Alberto are here. They sponsored that development. So thank you again. It's now open source. So I wonder if I should briefly show that. If I knew which version is it. So that should look familiar. That's the KNIME Analytics Platform. And let's say the workflow diff, the problem that it addresses is, why is that? Okay. Hold on. It's the wrong KNIME. Okay, so this is KNIME. That should look familiar. The workflow diff, the problem that it addresses is when you are a workflow designer, you create your workflow, then you use it for a while, then you don't use it for a while, then you make changes to your workflow. You want to save it in a new, let's say, under a new name, and you forget what you have changed. And the workflow diff allows you to select two workflows and diff them. That becomes particularly useful once you use it on the KNIME server, because then you can also snapshot your different versions or revisions. So you have a revision of workflows, and so you can show the difference between those. Let's take an example. So that's just a random KNIME workflow, one of these basic examples that we distribute as part of any new KNIME installation. And then you just, let's say, yeah. The other thing I need to show is these curved connections. This is really cool. If you are, if you are new to KNIME, you will say, okay, but if you are a long-term KNIME user, you say, ooh. Okay, so back to workflow diff. So let's assume I open that workflow and make some modifications to the workflow and say, I just take the row splitter and replace one of these nodes. That feature you know, I hope. Okay, so just to make sure again, take any node, drag it on, and it will replace it. You can also do some more fancy stuff like dragging that on a connection, and it will automatically insert that node. So I've made some modifications to my workflow, then I go here, change some, I have no idea, change some parameter. Now I make changes and I wonder if I should override it or save it under a new version. Better go here, save it under a new version, and now out of the sudden I have two of these. What has changed? And this is now where the workflow diff comes in. You right click both of them, you go to compare, and it comes up with that view, which show you, okay, there are all these nodes that it has in common, so I'm not interested in those. And then I see which nodes have been added or removed, and there's also apparently a diff in that particular node, and then you see one of these parameters has changed. So that's quite useful. Going back to the slides, now it has to switch again. That is, something I've shown. The other piece of personal productivity is what we call Metanode templating. So the idea of a Metanode is that you encapsulate part of your workflow into this Metanode so that you have a more tidy workflow. Call it a procedure or function, we call it a Metanode. So these Metanodes, what you can do with them, now that personal productivity is open source, you can take it and then there's a context menu and you right click and then you save it back into your KNIME Explorer, and then you can reuse that Metanode either in the same workflow, or also once you put it onto the KNIME server, you can share it with your team. So they could use that also. And you can parameterize it, so you can have a custom form on top of these Metanodes. So that's what Metanode templating is. There's a bit more, like calling out to other workflows. There are nodes in there, but I guess I can leave the whole story later to Iris and Phil, because they're going to talk about Model Factory and how to orchestrate a bunch of KNIME workflows. This has been released in July, and as Michael also, we plan in December we'll also make the open source, make the big data extensions open source. Everything that concerns big data is going to be shown later by Tobias after a short break. Okay, now I would hand off to Tobias to talk about something else, the speech recognition, and then it's up to Kieran to talk about text processing. Let me
the first show the slides. Perfect. Thanks a lot, Bernd. Okay, so with the last release, we released the new KNIME audio processing extension, and this one comes with new audio cell types so that you can work with audio cells within KNIME. And you can also listen to audio files within KNIME, so we have an audio viewer. And you can extract acoustic features from these audio files in order to have the numerical feature vector, which you can then use for classification or any other machine learning model. And we have also integrated several speech recognition nodes. So let's have a look at these. That's this one. So I think it's the best just to show the KNIME workflow. Let's maximize this one. So here I read in 3 different audio files from KNIMers, from Heather, from Jeff, and Jim. And we can also listen to these. So we have this audio viewer. Let's have a look how that looks like. And then, for example, let's listen to Heather, what she has to say to us.
Welcome to Austin and enjoy the summit.
And then we have also Jeff. So maybe that sounds a bit different. Let's see.
Welcome to Austin. Enjoy the summit.
He tried to make a really Texan accent, so that was not too bad, I would say. And then we have Jim also from the Austin.
Enjoy the summit.
Okay, so all of them are saying welcome, also welcome from myself. And then let's see how the different speech recognizer work with these audio files. So we have 3 different ones. So one is the CMU Sphinx speech recognizer, which is also an open source project, and that works offline. So it's all on your machine, and everything is processed locally on your machine. And then we have the IBM Watson speech recognizer, which is a web service. So the audio file is sent to IBM Watson, and then they are sending back the results from the speech recognition. And then we have the Bing speech recognizer also. So for example, the nice thing with the Bing speech recognizer is if you use one of our cloud offerings on Azure, then you stay within Azure and the data is sent within the cloud itself. So there's not a lot of, it's all within the cloud then, for example. And then we have the audio data extractor that allows you to extract different features from the audio file, which are like the file length and the name and the type and so on. And we also have the acoustic feature extractor, which has a lot of sophisticated properties that you can extract, like the spectra, the frequencies, and all these kind of things. So let's have a look at the results from the speech recognizer, how they are doing with the different KNIME members. So there you can see that the CMU Sphinx has no problems recognizing Heather's voice. So Heather has a really nice English accent, I would say, or no accent at all. And then we have the Jeff, where it gets a bit more difficult. I mean, enjoyed, at least it gets enjoyed. And then with Jim, it's getting, so I would say. But then when you look at IBM Watson, for example, and Bing speech recognizer, they also recognize Jeff's voice, even if it was a bit of a Texan accent. And then, for example, one example of these features that you can use is that's this strong frequency. And this one you could use, for example, to distinguish between a male and a female speaker in this case. Okay, so you could build a model based on this information. And then earlier this year, I guess we released a video on YouTube, because sometimes people have a problem to say KNIME, and that's why we had this video here. Let's see.
KNIME. KNIME.
That's Phil.
The K is nine. Open for English.
Okay, so we had this video so that everybody knows how KNIME is pronounced and that the K is silent. And so we also had this audio file here and processed it by the different speech recognizers to see how they perform. And there's one thing that I want to point out is that for the CMU Sphinx recognizer, oh, sorry, we don't want to listen to that introduction. So the nice thing with CMU Sphinx is that you can give it your own dictionary. So you can tweak it to words and all these kind of things that maybe the other speech recognizer don't know because they are not that well known or something like this, right? So here we have created our own dictionary that contains the KNIME information, so the KNIME word and all these kind of things, and give it the CMU Sphinx recognizer so that it might recognize it better. And then when we have a look at the results for the different recognizers, then you see that IBM and Bing don't seem to know KNIME that well yet. I don't know what's the reason for that. But since we have this dictionary for CMU, it perfectly recognizes KNIME, KNIME Open for Innovation, Hello, and all of these kind of things. Okay. And that's the audio processing. And with that, I want to hand over to Kilian, who is talking more about the text processing. Thanks.
Okay, I'm very happy to show you the new text processing features since the last two releases. So in order to come up with one somehow consistent example to show the new text processing features and the new analytics features, we decided to use a sentiment classification use case or sentiment classification example. And first, we parsed some PDF files. Basically, we extracted some text from these PDF files. We created feature vectors, numerical feature vectors for these documents, and we used these feature vectors then for predictive modeling later on. I'm going to show you the first two parts, the PDF parsing and the feature vector creation, and Bernd then will talk a little bit about the new analytics features. So the goal is to build a predictive model, or the end goal then, to build a predictive model that predicts the sentiment labels such as positive and negative. Here you can see two examples. The first one is positive. It's clearly a huge Michael Jackson fan, and the second one is negative. We sampled a subset from the large movie review data set. This data set contains of English movie reviews with sentiment labels assigned such as positive and negative. And here we extracted 2,000 PDF files, 1,000 with positive reviews and 1,000 with negative reviews. And to parse these PDF files, I'm going to show you the new Tika integration. This is a very powerful parsing node based on the Tika library. And with that node, you can not only parse PDF files, you can also parse various other file formats. Second, I'm going to show you the new Stanford NLP named entity recognizer model, the learner and the tagger nodes. And then we have two new features, how to create document vectors with the document vector hashing node and with the word-to-vec integration. And the word-to-vec integration is a very powerful way of representing documents in a numerical feature space. Okay, so I will switch to the KNIME workflow. So it takes a few seconds to load. These feature vectors, they can become quite big and also the predictive models that we used. You saw two parts. The first part is the document reading and pre-processing part, and the second one is the analytics part. So here we used two of the TICA parser nodes, one to read the positive and one to read the negative files. I'll quickly show you the dialog of the TICA parser node, and here you can see that this node supports really a lot of files. So if you have many files are supported by this node, so you can really extract this. If you have any text that you want to extract from these files, use the TICA parser node. This node can, on the one hand side, extract text and other fields, for example, file path or a title and author. In our case, we just want to extract the content. But the node can also open embedded files and extract text from these embedded files as well. If you think of, for example, emails and attachments in these emails, they can be extracted. Or if you think of archives and zip archives, for example, they can be extracted as well. So after parsing these files and combining them into one consistent data set, we move on to the next step, which is building a custom model for named entity recognition. And therefore, here the new Stanford NLP-NE learner node and the corresponding tagger node is now available. This node takes a set of documents as input and a dictionary as input. And based on that dictionary, which is usually your custom set of named entities, a model is trained, which is then more general than the dictionary itself. And with that model, you can use that model with the tagger node. You can basically create your own named entity recognizer model. In our case, our dictionary contains of 5,000 English first names. So you can see them here. And just to show you that the model is able to find more than is just available in the dictionary, we did some filtering, and we found 65 words that has been recognized as named entities which have not been included in the dictionary before. So you see, for example, names like Katja and other names, they have been recognized by the model. So in the next step then, after some pre-processing, we are ready to build document vectors. The first set of vectors is created by the document vector node. This is not something new, but just to show you that it's still there. And now two new integrations are shown here. The document vector hashing node creates also document vectors, but on the term hashing trick. And this basically allows you to execute this node in a streaming fashion. So this node is streamable. This means that this node can be processed much faster than the regular document vector node. I'll quickly show you the dialog of that node. In that node, you have to specify the number of dimensions of your output vectors, and you can specify the hashing function and some other settings. And then this node will create row by row, document by document, one vector for each document. And last but not least, the doc2vec integration. This is based on the word2vec integration. According to there is also a word2vec learner node. As you can see here, we use the doc2vec learner node. With the word2vec learner node, you basically create a vector, a numerical feature vector for every term. And with the doc2vec learner node, you create a numerical feature vector for every document. This is a model that has been created. This is basically, it's a neural network, a recurrent neural network. And from that network, vectors can be extracted, and these vectors are then used later on in our analysis that Bernd will show you. Okay, that was my part. Thank you.
I guess a nice story about what Kian has shown here is that we are, again, I mean, this is a text mining extension, but what we are doing is we are integrating different libraries like TICA or the word2vec, which also comes from a library that does deep learning and that provides the word2vec functionality. So it's not really something where we have we have done the integration, but we have not implemented that algorithm. But without KNIME, that you have a very hard time to do that. Okay, let me continue with that just on the analytics side. What I wanted to talk about more, but then I was told I shouldn't talk about all of these details because we have separate slots and also tomorrow. The one thing that I wanted to highlight is that we have rewritten the logistic regression node that is available in KNIME. We have done some literature review and have found a different solver that solves us that optimization problem, and it has much better scaling properties. So that can also work on problems that are over-determined on large data sets, etc. So that's quite useful. It's and logistic regression is one of these the nodes that if you don't know the problem exactly, it's something that you poke around with. And then the other two pieces that those were really a lot of work. The deep learning integration, so we have started to work on a different deep learning integration based on the Keras framework. And also we have worked on the integration with the H2O machine learning library, the thing that Michael mentioned already. Those two pieces will be shown in more detail tomorrow by Christian and by, actually also by Christian and by Mark. So I would just skip over them. And in terms of, let me quickly go through the KNIME workflow again and see how this works in case you haven't, this is not the right instance. Doing some analytics with that. So this is a Metanode that Kilian showed. So if I go into that, this is what you will recognize. So all of these different ports give me the different descriptors of my data, and now I go into this analytics node, and it's something fairly simple. So it's just applying different algorithms to your data stream and doing some figuring out what the performance of different algorithms is. So you have your different input data. If I just open the first input, that's the document vector, and the second one will be the hashing node, and the third one will, in the end, it's your documents which hide in this particular column. So there's more than just the header here, and then a bunch of numbers. And you need these numbers in order to do analytics, obviously. And if you get these numbers right, then the analytics problem will be very simple, but it's very hard to get these numbers right. Okay, so you do some more pre-processing. If you want to be fair, you also do the splitting into training and test, and then you can try different algorithms here. And this is just 4 random algorithms that I chose. Something like gradient boosted trees, random forest, something that you always try when you are new to a certain problem. Then I've also looked here at using Python. So if you can't read this, this is a Python learner node. So if I open that one, that for instance imports something from scikit-learn and learns some neural network that is then in Python. And then also the logistic regression node, which again, you choose your the features that you want to use, and then here we have our new solver that will work also on large data sets. And then you have the predictor nodes. You have different predictors for different models that you are training, and then you can combine them all again into, let's say, into this Metanode that does some more processing of it and gets it into the right shape. So you get your predictions for the different, or let's say the probabilities for your different algorithms and the predictions, etc. You have the true class that you wanted to predict, but that you didn't use during the prediction, and then obviously you can just plot it in a ROC curve and then see how your different algorithms perform. On this data set, they all perform equally well. There are small differences, and then this is how you then play with a tool. You try different descriptor spaces. You see how that works, and then if you want to continue that further, you can build more metanodes, you can do cross-validation, you can build different ensembles, you can build ensembles of these different algorithms all together to come up with a model. That's the flexibility that Michael mentioned. This is what KNIME is really, really good at, to give you the freedom to kind of munch all your different models together. going back to the slides. The other thing that I wanted to mention is that we have worked on a new Python integration, which is now part of KNIME Labs. So KNIME Labs is kind of the category where we have all these nodes that eventually will be promoted into a standard KNIME release. The nodes that we have here now support Python 3, which was one of the motivations why we did it. They are much faster than the previous Python integration, and these nodes will also be the new Python integration as of December 6. The other reason why we did it is because we needed that for the deep learning integration that we are going to see tomorrow. So also a bit more work has been done on the Java Snippet. So Java Snippet is one of the scripting nodes that you find in KNIME. If you can't find a node that solves a particular problem, Java Snippet may, often, let's say, makes your workflow a bit smaller, but otherwise, often you can also avoid it. So if you're not a Java fan, that's completely fine also. What we added to the Java Snippet node is the ability to understand different types of data. So there's one way of extending KNIME. It's not just by adding new nodes, but also adding new types like documents, audio cells we've seen, molecules, images, etc., etc. So for instance, in this case, there's now a Java type RO-mol, so some molecule type, and then you can use some API that is defined in that library. I have no idea what that all means, but apparently it's useful. And then the other thing that I need to mention is that we also have worked on all these date and time handling nodes. So previously we had one type for date time representation, and that has now split into multiple different types, and that gives you all the flexibility. If you've been to the KNIME training yesterday, at least the user training, you probably have seen those nodes also, the string manipulation node. So whenever you play with variables in a KNIME workflow and you have to give it a different value, then these nodes will become very handy. So that was a bit of a, let's say you needed more nodes to solve a very simple problem before we had those nodes. So there are these three nodes, and that's all good. Okay, so now we'll make a small break and have Rosaria talk about not new development, but about something that we've done on the education side, and then we'll hand over to the server side and deployment, and have John and Greg talk more.
Okay. Okay, so now to learn something more about all these new developments, these new nodes, and how KNIME works and what to do, we have prepared a few new possibilities to learn. The first one is the e-learning. We have a new e-learning course. We had it already in March with only ETL and data access. We have expanded it in the last months with analytics, control structures, and visualization. So you can access it here, and we are going to change the title because the title was only for data manipulation and ETL, but now it's going to include also analytics and all the other parts of the data science cycle. We have around 50 small units. Each small unit has exercises, so you can try and test if you have learned enough about that particular unit. And all the exercises and all the solutions are all available on our example server. So we take care, every time we do a new unit, we take care of producing a workflow that then can be uploaded on the example server and then consumed by all of you as an example for that particular thing. At the end, there are also some final exercises to test your full knowledge about KNIME. Check the section 1.4. This section contains an overview of all the things that KNIME at the current state can do. All the things that can do in data access, all the things in data visualization, all the things in model training, deployment, all the phases of the data science cycle. This is a little note. Those are the videos that we made for Gartner. Every year Gartner tests us about what we can do with KNIME. So we produce a number of videos, and this year we have fragmented them, and we have put them for you on the section 1.4. So if you ever wondered what we tell Gartner, there it is. You can check it. All these slides for the courses are now available as PDF. If you go to the course webpage on our website, you can download the description, and at the end of the description, there is these slides can be downloaded here, and you are going to get the PDF file for all your slides. The KNIME Press. The KNIME Press, we have the two historical books, so the KNIME Beginner's Luck and the KNIME Cookbook. We have added this year the collection of blog posts on the blog post series Will They Blend. All the Will They Blend, I don't know if you know that we have this Will They Blend blog post series. We try to blend the weirdest and possibly complicated data sources that we know of. We have around 20 blog posts now on that series. So if you're interested in blending, I don't know, Google BigQuery, Hadoop Hive, YouTube metadata, video metadata, all these things are available in this blog post collection here. I and Vincenzo, we are also working on a new text processing book. It's going to be ready soon at some point. So keep in mind that something else is coming up in the KNIME Press. Online learning. We have started an experiment. It's going to be an online course, so it's not like the e-learning course where you have videos and you just learn by yourself. It's going to be a real course with a teacher, but it's only going to be remote. So it's an online course. The first experiment we will run with Joe Porter's group in November, December. It's 4 modules, 1 hour each, with exercises. So we do this 1 hour explanation, then we assign exercises. People are supposed to do them at home, and then next week they come back and we correct the exercises together. At the moment, it's only for the basic course on KNIME Analytics Platform. If it works well, which we hope, we are going to extend it to the advanced course, and we are going to extend it, for example, to text processing and other courses that we run. Yeah, so if you're interested, send us an email to education@knime.com. We are going to run a series of webinars in 2018. So we are going to start with the data science cycle. We are going to give an introduction to the KNIME Analytics Platform. But then we are going to move also to data access, deployment, database, the logistic regression, ensemble models, and deployment, and all those things that are also important for the data science cycle. And finally, if you really want to learn in person, we have organized a series of Learnathons at meetups. The Learnathon is kind of an extended meetup event, lasts usually 3 hours. We have the first hour of small presentations for the new people and also about the data science cycle. I have learned in my experience that a lot of, especially the younger data scientists, they know how to train model, but then they don't know what's all around the model training. So we are going to explain about the whole data science cycle. We are going to separate in 3 groups. One is going to focus on ETL exercises. One is going to focus on model training. And one group is going to focus on deployment exercises. We have already done the first one in Austin with Jim some 2 months ago. And it was very well appreciated. So we have a few more planned for London, Berlin, Zurich. If you want to host one, please let us know. Okay, so that's my part.
Hi. So I'm going to talk a bit about the KNIME Server, and then I'm going to move on to talk about the how we're using the cloud with the KNIME Server and also with the analytics platform as well. So just to remind you of what Michael showed this morning about how the KNIME Server fits in to the KNIME software pieces. So this is really a standalone piece of software that the analytics platform can work with to allow you to share your data, share your workflows, and I have some nice slides here. So you can share your data, you can share your metanodes and reuse those pieces of analytics and ETL functionality. You can share your workflows with your colleagues. Of course, once you've built those and you start sharing them, you need to probably control the access management to those workflows. You want to actually execute workflows either on a schedule or just to get the power of the KNIME Server hardware. Or you may want to integrate with REST services or services that can call REST-enabled things, so the KNIME server is REST-enabled. Or you may want to deploy something via the web portal. So that's just to remind you if you're not sure, and we've got a demo of the KNIME server outside, and I'd be happy to show you some more. So there's a couple of nice kind of smaller usability things that we've done in the last year. And one of them, the first one, is the deploy to server context menu item. And Greg will show how that works in the later on. But basically, you can right-click on a workflow, choose to deploy to server, and then you can just choose where you want to put that on the server, and it will be uploaded. In a similar way, if you want to find your workflow on the web portal, you can just right-click, open in web portal, and then your workflow will open in the browser, and you can click through and make those changes there. I mentioned authentication being pretty important for the KNIME server, so being able to control who accesses that data on your workflow or on your server. And there we already integrate with LDAP and Active Directory, but the new functionality there was the single sign-on of the web portal via Kerberos. And the final really nice thing, in case you run into problems when you're running the KNIME server and you want to get in touch with us and figure out what's going wrong, there's this download server log files, and that will just gather up all the log files from various locations, and you can send them on. And we've also put together some workflows that can kind of start to analyze those log files and point things out. OK, so moving on now to the KNIME in the cloud and how we support or why we deal with the cloud. So we want to basically be able to bring our analytics that we build in the analytics platform to our data. We want to be able to work more fast. We want to be able to work more agile. We want to pay for what you need. And it also enables kind of new ways to work with your data. So we chose the two leaders in the cloud, AWS and Azure. And we started to put our software there available in the marketplace. And so far, you can basically get the KNIME Analytics Platform pre-installed, pre-configured on the AWS marketplace and on the Azure marketplace. And you can also get the KNIME Server, 5-user, the KNIME Server with the big data extensions configured, and the KNIME Server with a bring-your-own license. So you can get the license from us, or you can pay for the software through the marketplaces. So how does that look? You can basically go, in this case, to the AWS page. You can search for KNIME, and then you'll find our marketplace offerings, and you can just kind of launch them with one click. That's a great way to kind of just get started and get a feeling for the software. It's also a great way to kind of just deploy that without having to kind of worry about getting access to servers and installing stuff, and it's just all pre-configured and ready to go. So with cloud connectors, so once you've got your KNIME server available in the cloud, you might want to work with those cloud resources that are really nearby your data now. Or you may want to work with your analytics platform as well, just from your local desktop and connect to these different cloud resources. So things like S3, blob storage on Azure, or some of these managed databases like, for example, the Azure SQL DB. So first of all, we built these connectors for Amazon S3 and Azure Blob Storage. And basically, you can then connect to those services using KNIME's file handling nodes. So you can do things like list directories, list files, upload, download files, delete files, and give access to those files. So here's just a simple example workflow. And all I've done is I've added in my S3 credentials to this connection information. You can also connect to the default keychain with AWS. And then here I can choose the file or the object that I want to access. And then I can basically pass that information into my file reader and just read the file into my analytics platform. Of course, if I'm running on the KNIME server or running in the cloud, then of course this data access can be super fast. And that's kind of a pretty handy way to work with those bigger files. We've also got this, for example, the SQL Server connector, and that's also configured to connect to things like Azure SQL DB. So I can just launch a database in Azure or in a managed database in AWS, and just connect to that using the normal KNIME database handling node. So it's just really, really easy to get started with those kind of cloud resources. Okay. There's even more connectors that we've built in the last year. Amazon Redshift. So for those of you who don't know, that's a fully managed data warehouse. It's got an SQL interface to it, and it allows you to run these SQL queries in a distributed and parallelized fashion, so it kind of scales to large data sets. And the Amazon Redshift connector that we've built just integrates seamlessly with the existing KNIME database connectors. So it's kind of really easy to get started. If you know how to do database queries in KNIME, you know how to connect to Redshift and query there. We've also built connectors for Amazon Athena. So that's a serverless interactive query service. Again, it's got a SQL interface, and you can just use Athena, again, with the existing database connectors. So I'm just going to show the kind of steps that you would go through to do that. So with the Amazon S3 connector again, I'm going to configure my connection, and I pass that into my list remote files node. I can then list all of my CSV files in this example in a bucket, and I'm going to pass those files into this Metanode here. I'm also going to configure my Athena connection information, pass this into the Metanode, and basically in here what I can do is I can peek at the top, let's say 1,000 rows of those files, and use that to determine my database schema. So that I can assemble a create statement. To do that, I'm using some of the Python nodes in there. And once I've assembled that create statement, then I can create my database, and I can just query that here with the database table selector. And this is kind of a really nice example, I think, and Greg will talk about this in the next bit of the talk, about how you can kind of then use this data to do some guided analytics on. So myself as the kind of the data architect, I can just build up these queries and make it pretty easy to then just say, yeah, here's the access to your Athena database or to your Redshift data. And now, Greg, go off and do your thing and do analytics and make that available for people in the organization. The other thing, once you've got these S3 connection set up, you can also connect to CSV files, ORC files, and Parquet files, and just read them directly into our Spark settings. So you can create Spark data frames, do something with that, and then again write them back to CSV, ORC, or Parquet in S3 or Blob storage. So to summarize, we've got data storage with Azure Blob Storage, Amazon S3. You can connect to databases, Azure SQL Server, all of the Amazon relational database managed services, so MySQL, Postgres. You've got data warehouse connectors to Amazon Redshift, Amazon Athena, and you can also connect to the Azure SQL DW using the SQL node. And you can also connect to Azure HD Insight or Amazon EMR with the big data extensions. And finally, there we've also got the analytics platform available on the Azure marketplace and the AWS marketplace. KNIME Server also available on Azure and AWS marketplaces, and all of these connectors you need to go on around there. So, thank you very much.
So I get to be the last one between you and the coffee break, which hopefully you'll pay attention and nobody runs out in advance. I'm going to be talking about guided analytics. I do a very quick overview of what I mean when I say guided analytics. I think it's what most of us mean. We're talking about coming up with some kind of connection between someone who needs data or data analytics. This is this person on the left-hand side. That would be perhaps a business analyst or a manager, decision board. The right-hand side, we have a KNIME expert, somebody who knows how to drive KNIME, create new workflows, do analytics. What normally happens in most organizations when these two need to work together, the one goes to the other. And it's normally the expert sitting at their computer or sitting at the business analyst computer and doing some work for them. This is a great way to communicate, but it's not very efficient because every time the business analyst needs something new, they have to go bother the expert again. What we'd like to do is come up with a way to allow this person and this person to work together where the KNIME expert creates an analytics workflow or a series of analytics workflows that kind of captures their best practices, and they can then provide that to the business analysts in a way that the business analysts can actually interact with the data, they can build their own models, they can explore the data without shooting themselves in the foot. So one of the things that Michael has called this is analytics with training wheels. Guided analytics workflows. Okay, so what we're doing again is enabling people that are not KNIME experts to work with or explore or analyze or learn from the data. These are typically deployed in large organizations via the KNIME web portal. It makes heavy use of interactive JavaScript views for the user experience. So when I talk about this, when I'm talking about what's new in guided analytics, really what I'm talking about is what's new in our interactive JavaScript views. Now for people who don't have the server, there's a big bonus here that the JavaScript views that we need to build for JavaScript analytics are all using open source components. So everything I show you here, you can do via the server, but you can also just do in the analytics platform itself, right? So if you're working alone, you can work with it in the analytics platform. If you want to deploy to others, that's our commercial product. Here's a list of what I'm going to be talking about. We have on the JavaScript view side, I'm going to show you a series, so one fairly long, not fairly long because we have to get at the coffee break, one truncated user story, working with some census data that uses a number of the visualizations, and then some standalone things that show the network view, a stacked area chart, and the sunburst chart. Throughout all of this, I'm going to be taking advantage of new interactivity features that have showed up over the last year. Most of this showed up in KNIME 3.4, including range filter widgets, views that are linked to each other, and then some other nice things inside of KNIME. Before I get into too much details, let me just start with a demo, if I can find and make this all work. So what I have here is a very simple workflow. It's simple because I've captured all the complexity inside of these metanodes. Essentially what's going to happen is I'm going to read some data in. This data that I'm reading in is an excerpt of the US Census data. For people who don't know it, there's a large quantity of census data that are available as CSVs. You can just download that and you can do all kinds of interesting analysis with it. That's what I'm doing now. I'm going to start by filtering that, so I want to get a little bit of a sense of what's in the data. Let's take a look and see what happens there. I'll just execute this and then we'll talk about what happens inside. What is happening, or what you will see, hopefully. I have two JavaScript tables here. So there's a table up at the top. This is showing a summary of what's in the data with it grouped by this cow column. Cow is category of work. One of the things you'll notice about this data set is it has really terrible column names. So there's a text document you can download that explains the column names. I always forget. I remember cow because I live in Switzerland, so cows are important. What we're going to do later in the What's Cooking session is I'll show you an easy thing that we've added, or a node that we've added that makes it really easy to change these column names interactively so I can fix the problem. And the next workflow I'll show you after the break will have better column names. For now, you're just going to have to bear with me and remember that cow is category of work. Age P is the age. Why they put a P on the end, nobody knows. Anyway, so you can see when I did group by category of work, that's what I'm interested in here. I have a variety of different values, and -1 is the missing value. So for this particular person, when they filled out their census form, they did not check the box that said what their employment status was. I am not interested in those. I want to explore the data and really think about the category of work. So I'm going to filter those out. But let's get look a little bit more about what's in the data. If I select a row up here, those show up in the table down at the bottom. So this is a kind of a classic master detail view. This is my master table. When I click that down below, it shows me all of the rows where the category of work is 7. So now I can go in and look at below and see all the columns. I can sort by age. I can search. I don't have any interesting text columns in here, but I'll search by 2001. I don't find any because it's a number, not text. But I can explore the data just by continuing to select here. Every time I select, it changes what's visible below. When we move on, what I really want to do is I want to bring over everything that's not category of work -1. So let me select those, and we'll move on to the next piece of the workflow. What some of you may not have known is what I just did is something that was not available in KNIME versions before 3.4. So I had two views, two JavaScript views that were talking to each other. That's new capability. And that wrapped Metanode view I showed that had both of those on this, visible at the same time inside the KNIME Analytics Platform, that's also new functionality. That interactivity within the Analytics Platform itself is something new. Before, what you had to do if you wanted to see both together is upload it to the server and then look at that page. So by allowing it to go to see that in the Analytics Platform, we make it easier to do the guided analytics workflows. At the same time, we make it possible for you to do a lot of this work on the Analytics Platform itself, so on the purely open source side. So I filtered that data set down. I removed those 23,000 rows. I can now build a decision tree. I'm going to build a decision tree using the rest of the descriptors for that category of work column. In this particular case, I'm not really interested in how predictive the decision tree is. I'm going to use it as a tool to explore the data. So I want to let the decision tree pick the variables that divide things up by category of work, and I'm going to see what I can learn about the data using that tree. So I built the tree. Now I'm going to take a look at it. This is another one of those another one of those wrap metanodes. Let's take a look and see when I run this. This is going to show me the new decision tree view, which is up at the top here. Unfortunately, okay. So we have the new decision tree view. It's showing the first two levels of the tree. So this is the category of work column. By default, the majority of the people in that data set were working for for-profit companies. So the first level of the decision tree is for-profit. The first split in that tree is their self-employment income. So if they have a self-employment income, they're more likely to be self-employed than anything else. I can expand this though and see it's not everybody here is self-employed. So there are people working for companies who have self-employment income, and there are people here working for not-for-profits, for for-profits, and the government. So we can continue to browse down through the tree. This wage P, this is their overall wages. So if I get down to this point, you can see I have 1,032 of 1,039 rows are self-employed people. We can read this decision tree and see what we've learned. So someone who has self-employment income, but their overall wages are low, are self-employed. That's not necessarily happy for the people in that group, but it's a nice clear lesson that we can read out of this. The other thing that you can do with these tables, these also participate in selection. So I can, on the decision tree, I can click that node. Over here in the table now, it'll show me the individual rows that correspond to these 1,032 self-employed people, so I can explore a little bit more. So again, I have two views that are interacting with each other, visible in the analytics platform. This decision tree view is also one of the new pieces. The JavaScript table is one of the new pieces. The last thing I'm going to do is use a parallel coordinates plot, which is one of the other new visualizations. I'm going to use exactly the same trick we did before of having a series of coupled interactive visualizations. So this is the census data. I've pulled a number of the selected number of the columns out, which is the sex of the person, their age. This is their English capability, their ability to speak English, the category of work, and this is another measure of overall income. Again, I have a table on the left-hand side, and up top I have a range slider. I can use this to filter what's visible in the parallel coordinates plot. You see the table is changing too. This is changing what's visible in all the tables. And then, of course, I can take this thumb around and move it as you'd expect to be able to do and change the data, change what's visible. The parallel coordinates plot has some nice features. You can select on the individual rows. I'm going to tell the table over here to only show me the ones that are selected. I can select on the individual rows. So now I've selected all of the people who have a category of work of government. I can then go in and refine my selection by picking the ones that can speak English well, not very well, or only English. And you can start to analyze your data purely by expanding a selection on the parallel coordinates plot, right? So I'm subsetting my data down. The table is showing me all of the rows that are visible in that. Okay, so again, it's a series of interacting pieces. This range filter is something that's new. The parallel coordinates plot is something that's new, and we've seen this before. The parallel coordinates plot has a lot of other nice functionality. One of the things that's interesting about this is that it's really useful if the columns that are next to each other have some connection to each other, but if they don't, it really looks like a mess. So I can rearrange things. If I want, I can rearrange the columns to try and find this nice connection. So you have a lot of interactivity available in the widget. Okay, everything I've showed you to this point is using purely open source stuff. It's all in the analytics platform. What I would like to do now that I've done this analysis and that I have things set up, I'm going to change hats. So I was just the KNIME expert. Now I'm going to become the business user, or I would like to provide things to the business user. My last job wearing my KNIME expert hat is I'm going to take this workflow and upload it to the server so that the business analyst can work with it. John mentioned this already, that we've made it easier to do this, so I just have to find my workflow over in the Explorer. I can right-click on this and just select Deploy to Server. I only have one server mounted, so it shows me that. I'm going to copy it into the demos directory. I'll overwrite what's already there because I made some changes. So now I have on the server the workflows is available. So for those of you who know the server, anybody else in the group who has access to that can now download that workflow and work with it. Because this has web portal nodes, each of these wrap meta nodes corresponds to a page on the web portal. Because that's there, I also have a web portal application. So I can go to the server in my browser and find that web portal application. I can never remember what the URL is to our server, never. What we need to go, and that's all too complicated for me when I'm wearing my business analyst hat. So we've added some functionality to make that easy. I can go connect to the, when I right-click a server workflow, I now have this open in web portal option, so I don't need to remember the URL. I do this and it'll open my browser for me and go to the right place, which I love. So I log in, it's going to get me to my workflow. And I'm in the web portal. That's the workflow that I was just working with. It's now loading the data in. It's pulling up that first view that we saw before. You can see we get the same thing. I will go through. I'm not going to take all the data through this time, just to move a little bit quicker. One of the other things that's interesting in this is when it's running in the web portal, there's a couple of extra settings available, and I'll show you those when the next page comes up. This is building that decision tree again. So there's my decision tree. We're getting basically not the same results as before because I didn't pull all of the data over. When you have these together, when they're on the same page, it's convenient because I can make changes here and have them show up on the other page. These do sometimes get a little bit cramped though, so it's nice to have a somewhat larger view. I can right-click and expand this out to make it full screen. So I can really focus on what's going on in an individual widget and then just pop back out. You can do the same thing with the table. So if I want to browse around in the table, I have a lot more flexibility just by going to full screen mode. That's only available in the server for technical reasons. But hopefully you recognize this is the same thing we were seeing in the analytics platform, right? So I had exactly the same views visible in both. This is now available to the business analysts just in the web portal. They don't actually have to use the analytics platform at all. All right. I close this and go quickly back to my slides. So we just saw this. For people who don't know the analytics platform, each of these wrap meta nodes becomes a page. So this was the first page that we saw in that application. This was the second page, and this was the third page. So this was the filtering, this was the decision tree, and this was the parallel coordinates. In the web portal, I go through those step by step. The stuff in between happens magically. In the analytics platform, I run them each individually. Okay. That was where the first set of views. Let me show you this one, which I find particularly, it's one of the most visually pleasing views that we've added. Unfortunately, it only works for very limited kinds of data, but it's fantastic for when it works. This is a stream graph. The data set that I'm going to work with this is different. This is a set of data pulled from Twitter. So what we did is, Rosaria did this. She mined the Twitter feed and pulled a bunch of posts. In this case, it's 30,000 posts. KNIME was mentioned somewhere in these posts. So that's how we filtered them down. It's not just a random Twitter stream of hate. It's KNIME. We have happy users, so that if you did a sentiment analysis on this, it would be good actually. This again, you should recognize one of these wrap metanodes. We can look inside this and see what's in this frequency filters. Can see what we have in here is that's too big. We have a series of range sliders, so there's 3 of those range sliders this time. A JavaScript scatter plot and a JavaScript table view. So when I open up this view, we're going to see 3 range sliders, a table, and a scatter plot, and they're all connected to each other. So let's go see what that looks like. Again, I can just open up the view. Here I have a whole bunch of tweets. I have a table with the 1,800 of the entries, so I've subsampled this a little bit, and there's a scatter plot showing a couple of different variables. Here are my range sliders, so I can mess around with these and change what's visible. Let's see. Yeah, I can do that when things are working, so we're going to ignore the demo effect. Sigh. It's funny, I did this at the Spring Summit when this stuff was all in beta and it worked, and now that I was overconfident because it's no longer beta and I screwed something up. Because basically what I've done is I've downsampled those posts so that I have, I've downsampled the hashtags and the @ mentions in that post that there's only 12 of them left. Those are with those range sliders at the top. I'm now going to show the stream graph. And what this now does is it goes through the posts that are left and counts the occurrences of those 12 terms. And the stream graph shows those as a function of time. So this data visualization is really, really good for time series. So time series with a limited number of series that you want to show at once that have something to do with each other. So you can see these are, we sampled the feed from October of 2016 to September of 2017, so just about a year. This ended, well, I'll get to that in a minute. I apologize, this is not October, these are week numbers. This is week 10, this is week 50, this is week 2, and this is week 9. So this ended right before the Spring Summit last year, it's not September. What you can see is that mentions, the biggest mention in here is @KNIME. I can pull the other guys back up. And then beyond that, we have some other ones that are fairly substantial. This is big data. I'm interested. I was very careful in selecting the filters on this so that I came through. So I got to do some vanity surfing while doing this. Let me get one where it's just me. I'm not very good with colors, so I can't really find that. There we go. That's me. So I can see my mentions. It's nice to do. Anyway, you can see interesting things in this just by looking at it. So the mentions of everything drop around between Christmas and New Year, so people are not using KNIME during the Christmas vacation. That's something we need to work on, so that's for the evangelism group. There's a big spike around the December release, so that's our December release. There's a lot more social media activity. This is just before the summit, so it's getting ready for the Spring Summit. Things really spike. You can go back a little bit. This is the July release. This is our this was the other springs of the summit in Berlin. Yeah, from the previous year. So you can get in and understand the data. It's a useful visualization for very particular data types. Okay, the next new thing that we added is the sunburst plot. This is another really cool one. There's something that you are supposed to use this for, which is clickstream data, so I'll show you that. So I've read a bunch of clickstream data from a website log and bring those in, and the sunburst chart makes it really easy to look at that kind of sequential data. So the first ring is the first entry in the clickstream. This is now the second entry in the clickstream. So these are the users who went from home and then to search You can see that's 5.9% of the users in the data set. Then they went back to home, and then you start to get into really fine slices by the time you get out into the outer rings. But this is a really nice visualization for this kind of stream data. The KNIME widget shows you up top, you have the breadcrumbs that show you the pieces, which is quite cool. And this interacts with the rest of the selection framework as well. So you can go and select subsets of this and then have a table show you the pieces. I apologize, I haven't prepared one of those for this piece. So that's what you're supposed to do with it, which is pretty cool. I have played around with a little bit and found some other stuff that you can do that I think is even more cool. So I'm going to spend more time on that than what you're supposed to do. This is another data set. This is looking at mobility of European professionals, so people moving from one country to go work in another country. This has been a fairly high news activity topic over the past couple years. And there's a really good data set to go in and look at what's going on. So this is not a clickstream anymore. This is looking at hierarchical data. So the inner ring is where the professionals start. So 13.2% of the professionals in this data set started in Germany. They were Germans. 3.34% of the total data set were Germans who went to Switzerland. Of those, you can see the largest portion of those were in the medical field. So those of us who live in Switzerland, we know almost all the doctors in the German-speaking part of Switzerland are German. There are almost no Swiss doctors in Switzerland. And then you can go up and you can see that also broken down by year, and you can see there aren't large changes year to year. So for this kind of hierarchical data, this is also a really neat visualization. You can do other things in this. So there's the, I can go over here where I have, this is Poland going to the UK. The Brits have this thing about the Polish plumber, but actually if you go in and look, it turns out that most of the Poles working in Britain are in education or in medical. The interesting thing through this, the doctors show up all the time. So doctors move around a lot in Europe. So that's one way of looking at the data. Simply by taking this table, the data table, and rearranging the columns, I can rearrange the order they appear. So this allows me, this version of it, starting with the origin, allows me to see where people start, where they go, and what kind of work they do. I was also interested, so that all of these doctors are going to Switzerland and to Austria and to the UK, all of the German doctors. I was kind of curious where German doctors come from, because they're all leaving. They must be coming from somewhere. There are doctors in Germany, I think. So this is another version of that same plot. I just rearranged the columns. Now the inner piece is the host country, so that's where the person goes. The interesting thing is Germany is down here. You can see they're quite small. So relative to the whole data set, 6.3% of the people are going into Germany. Most of the people going into Germany are doctors. That's no big surprise because most of the people leaving Germany are doctors. And then you can see they come from a bunch of different places. So there's no one large contributor to that. Switzerland, which is a really tiny country, and up here is one of these little guys. It's almost impossible to select. The Swiss don't leave Switzerland. But lots of people come. And most of those are doctors. We saw the German doctors coming in on the plot above, right? I think this is an interesting visualization, right? It's a nice tool for being able to do this kind of stuff. So that was the sunburst plot. The nice thing about this is I'm the moderator for the session and I'm the one who's closing it, so I get to go as long as I want. I have 4 more minutes. It's okay, Michael. Okay, the last one of these is looking at some network analysis. So this is one of the other new visualizations that we've added. One of the new interactive views is something for looking at networks. In this case, I've pre-processed a bunch of data. I'm using that to build a network, and I'm going to now do some analysis of the network. Because this is a network based on chemical data and that scares people, I'm not going to show what's inside the pre-processed data piece, and I will warn you that there are going to be pictures of chemicals on the next slide. So if you have nightmares from your high school or college chemistry, don't pay attention to the picture column that's about to show up. What I've done is I've built a network of a bunch of molecules that shows how they're connected if they're related to each other. You see it's kind of the same thing I did on all of the other visualizations. I have a slider, I have a network visualization on the side, and then I have a table. I can have the table show me only the selected rows, and then go in here and select a set of molecules and visualize those. So I have a bunch of different pieces. This particular network isn't very connected, right? There's a bunch of singletons. The singletons are kind of boring, so what I'd really like to do is get at this guy, this big clump. I have a range slider up here. This slider is the hub score. It's one of the network analytics that's built into KNIME. This is very similar to Google's PageRank. So it's really telling you how important a node is in a network, or it's one of the very good measures of how a node is and how important a node is in a network. So I'm just going to increase this a very small amount. I'm going to close the visualization. I'm going to reopen it and increase it a very small amount. Increase this a small amount, and what you can see is it basically takes all of those singletons and just throws them away. So those little subclusters essentially have no importance to the overall network. Now I have this much smaller piece. I can now really start to get into details. So if I can sort my table by that hub score. I can go and look and see where those are. So this guy, who has just the highest hub score, is right in the middle. It's surrounded by other things that also have a high hub score. So again, here the interactivity is going in both directions, right? So the table is changing what shows up or how things are highlighted in the network. The network also changes the selection in the table. And all of that, all of the rows, which rows are visible, is controlled by the slider up at the top. So it's just another example of the interactivity, all of that showing up in the analytics platform. If I were to copy this to the server, I would have the same thing available via the web pages. Go back to my slides. So we saw the stacked area chart, we saw the network visualization, and we saw the sunburst chart. I'm right on time, Michael, it's okay. Okay. We're going to have a short coffee break. We're back in here at 12, right? So in 15 minutes, we're back in here. We'll then follow up, we'll go on to what's cooking, so the things that are coming in the next release, as well as a big overview of the big data stuff that Tobias is going to do. Thanks.